All right. Identify whether each situation involves permutations or combinations. Explain how you know. Okay, choose 3 toppings for pizza from 25 different possibilities. Are we going to use permutation formula or a combination formula, do you think, for this one? Combination? Okay, now why did you say combination? Okay, all right. So it says choose right here. That's a good hint. And order doesn't matter, right? If you think about a pizza, right? If you have pepperoni, mushroom, and bacon, it doesn't matter if it's bacon, mushroom, and pepperoni, right? Or any other, that's a combination, okay? So you would probably do 25, C, choose 3. Okay? So this is combination, good. Okay, you choose a CEO, a president, and a vice president from a group of 20 candidates. Combination or permutation? Okay, permutation. Now, why permutation? Yes, because there are specific positions. So if there are if there's specific positions, that's order matters, right? Like in a race too, first, second, and third. How many different ways could Jimmy, Johnny, and Sally get first, second, and third? Order matters, right? Okay. Determine the number of outcomes possible when rolling 3 dice. 1 red, 1 blue, and 1 white. Okay. This may be a little bit tougher, but think about that. You're rolling 3 dice. Now, does order matter? Does order matter? 3 dice. What do you think? What are your thoughts? No? Or does it matter? Okay. Do you want to say why? Why order wouldn't matter there? Why would you say that?
Did you count like the total of all the numbers added together after you roll the dice?
Well, are you adding them all up? I don't think it necessarily says you're adding them all up, but you could be adding them all up. Now, here's the key: red, blue, and white. Okay, so does that change things? Okay, so if we had, let's say we had a red, and here's a blue, and well, white's going to be a little tough for me to draw on a white background, but let's say we have this. Okay, so you're rolling 3 dice, 1 red, 1 blue, 1 white. Does order matter? Okay, we have 1 vote for no. Do we have any votes for yes, or do we all agree? What do you think? The number of outcomes. I'm not sure that the colors matter. There's this little word in there. There's this little word. So does that mean anything? Sorry? Okay, so maybe we should multiply these. Does it make sense to add these? How many different ways could this, like 6, and then add 6 and add 6? If we're rolling them all at the same time, I think we need to multiply. So that is permutations probably then. This one's perm, this one's perm. Okay. So I think there's that and word in there. That's a bit of a hint. I like what you said. If it's a sum, it doesn't matter which ones we're adding. Maybe with the different colors and the and sign, I think we'll go with permutations there. Okay, so D, determine the number of ways 5 children from a group of 11 can start in a game of pickup basketball. Okay, so 5 from 11 in basketball. What do you think? Combination? Okay, why?
Because it doesn't matter what order.
Okay. If it's a pickup game, you could say it doesn't matter what order these guys are in. It's just 5 groups, right? Just groups. Now, some of you basketball players, right? I'm looking at some of you basketball players. You're like, no, that's permutations. Okay, I'm playing the post. Okay, big guy, whatever, right? So the order matters. I mean, you can argue that. That's fine. That's fine. I think probably the back of the book's going to say combinations. I'm not sure. So can someone check here the answers? I don't have the answers in front of me here. Yeah. Does it say permutations for D? Does it? Okay. So order matters if we're talking about specific positions. If positions don't matter, then combinations. But it does say permutations for 1D? Okay. So I think it can be argued either way, right? If it's just a bunch of guys like me that never play basketball, then it doesn't matter what position I play. I don't even know them, let's say. So, but if it's basketball guys, it's like, hey, I'm playing here, you're playing there. Okay, so an argument could be made for both, let's say. Okay, what about the other ones? Did we get the other ones right according to the book there? Or what? Yeah? Okay. Any questions on that? This one could go both ways, I would say. All right, that's number 1. we look at number 4 here as well. It says from a standard deck of 52 cards. Now, I don't know how many of you actually play cards or know. I know there's some students that don't know much about cards, right? But there are 52 cards in total, not including the jokers. But there are 4 suits, 4 different categories. 2 of them are red, 2 of them are black. There's hearts, diamonds, spades, and clubs. There's 13 cards in each to make up 52. And that's sort of the base that you need to know. It's kind of, the numbers start with 2 and go up to 10. And then there's Jack, Queen, King, and the Ace, the 4 cards other than the numbers. All right, so how many different 4-card hands are there with 1 card from each suit? 1 card from each suit. Okay. So how are we going to do that? 4-card hands. Should I start with 4 spaces like this, do you think? And are these going to, is this, okay. Does order matter here? Oh, that's interesting. Okay. If you have these cards in your hand, does order matter? Well, we do have a number of options for the first card, and a number of options for the second card, and a number of options for the third, and a number of options for the fourth, right? So when you're putting 1 and 2 and 3 and 3 and 4 in your hand together, I think there's going to be probably some multiplication that has to happen here, right? So how do I find out 1 card from each suit? So how do I find out how many, so clubs kind of look like this, right? Sort of. It's like a cactus, but anyways. So the clubs, okay. So how do I find out how many clubs I could have if I have 1? Yeah, there's 13, right? There's 13 in each, so you just say 13. You could do also, there's 13 and you want to pick how many? 1, okay? So that should be 13, right? All right, so for the spades, let's see if I can draw this any better. Oh, a little bit better. There's 13, pick 1 as well, right? And for the diamonds and for the hearts, those are both red. 13, pick 1, and 13, pick 1. Okay, so we figure we're going to multiply those, I guess, eh? You think? Going to multiply those? Okay, let's give that a try. So 13 times 13 times 13 times 13, or 13 to the power of 4. What do we get there? Is that
28,561.
okay? 20,561. Now, so does this look okay so far? Is this making sense? All right. Now, if order did matter, then what we probably would need to do is say, okay, we've got 4. How many different ways could we arrange these 4? Because let's say we have the club, the spade, the diamond, and the heart in this order. If order did matter, then we would have to multiply this some more by 4 factorial, because there's 4 different ways you could now arrange those. So in essence, we have to do it this way, but order doesn't matter still. Does that make sense? Okay. Okay, in honor of Rock Weekend, our big basketball tournament, we are definitely going to do a basketball themed question here. So, this question, guys and girls, says, how many ways can the 5 starting positions on a basketball team, 1 center, 2 forwards, and 2 guards, is that accurate? Basketball players?
No, that's not
There's
accurate.
3 guards, 2 forwards, and 1 center.
There's 3 guards, 2 forwards, and 1 center. Okay, so there's 6 players on the team. Right, thanks a lot. Your nose is growing. You're lying. Okay, how many ways could 5 starting positions be filled when the team has 2 centers, 4 guards, and 6 forwards? Okay, so how do we do this when we have 2 centers to choose from? Okay, so there are 5 starting positions. Okay, and 1 has to be the center. So how do I know how many options I have for the centers? There's 2 options for the centers because there's 2. Okay, so how do I use the combination or the permutation formulas here? Let's think about it that way, can we?
Well, just leave permutation and take the position.
Okay, so you think permutations because order does matter. So, okay. So if we have two centers, so you're saying two, pick one? Okay, do you guys agree with that? Does that make sense? No? Yes? No? Well, let's see when we get down a little bit here, because two pick one is, I mean, what about the forwards now? We have 6 forwards. So are we going to do 6 pick 2 or 6 choose 2? What do you think?
Well, they want the best.
I don't know.
So let's say we have, so we got 6 forwards and we want to select 2 of them. Does it matter if we go player A, then player B, go out on the court, or player B, then player A, go out on the court? Same 2 players. So does that order matter?
Usually starting positions are the best of the best. They don't want to take little Susie who doesn't know how to walk and put her.
No, but okay, we're not. Yeah, okay, but we're Susie who doesn't know how to walk is playing. Okay, I don't think we're picking the best of the best. What we're doing is we're just trying to find out how many different selections we can make. So does it matter? Like if there's 2 centers out there, 2 forwards out there, does it matter who goes first? Do you know what I mean? Or does it matter?
I think it
Like are those positions equal?
I think it is just because it's the starting positions. Like if it were like a random shift in the game, it would be.
Okay, so the discussion we just had was if player A and player B were selected for the 2 forwards, I don't think it would matter if it was B then A. Like these wouldn't be we shouldn't count both of them. So it's probably going to be combinations. So should it be combinations for this one too? I mean, I don't know if it matters, but should it be combinations then? Let's try combinations for everybody. So 6, choose 2. Okay? And then we'll keep going here. And then 4, choose 2. What? No, 4, choose 2. So I guess we didn't need to put the all 5 spots on there because we're taking care of it with this. All right, because we changed that, didn't we? We're going to try these formulas. Okay, so let's just see if this makes sense and if this matches up with what we think the right answer be, because this is what we decided. Should we choose? So what's 2 choose 1? 2. What is 6 choose 2? Is that one? 15. What's 4 choose 2? Okay. So if we multiply those up, what do we get? 30 times 6. Sorry, what? Yep, that's correct. Okay, so does that look like what we should be getting there? Okay, so these are the types of decisions you're going to have to make with this, whether order matters or not. And again, we're assuming that all of the forwards are kind of equal in ability or whatever. We're not having to match up whatever. So A, B, and BA wouldn't be 2 separate options. Okay, so choose. All right.